Afternoon, everyone. Today we are gathered here on the virtual platform of Google Meet for the webinar organized by Computer Department and Information Technology Department of Parul Polytechnic Institute. The title of today's webinar is Networking Basics Introduction to Networking Protocols. The speaker of our today's webinar is Mr. Himanshu Gurbani. He is a founder and support engineer at SSG Tech, which is a Vadodara based company. So I would request Himanshu sir to please begin with the session.
Sure. Hi guys. Hope you're enjoying your rainy season and the winter. Um, so the company started in 2019, and we started with an idea that we are going to support the big multinational companies and the users as well, along with the US clients that we were working when we were having our jobs. We were supporting US clients, so the idea came from that background. Uh, Coming to me, I have an experience of more than 10 years into IT and um, system administration. Um, I need to take a break of it for 2 minutes. I need to get some water, please. Okay, guys, I'm back. So let's start with the protocols and the networking. Apurva, do you want to add something, or if I'm missing?
No, you can continue.
Okay, yeah. So let's talk about networking. As you guys are in the information technology and a computer field, you guys might be knowing what's the WAN, LAN, and internet. So if you will say internet and intranet both are different things. Internet is for your the browsing things and sharing your stuffs and for the social media, but the intranet is for getting connected in a same network locally. um, as we say, like if you have an organization of 10 people, you need a networking that comes into the intranet. You have to be in the same network. So this is the just a small difference between that Let's talk about WAN. What's WAN? It's WAN is going to be like WAN is called wide area network. Okay, so WAN is used that this we can say like give me let me think about a good example for WAN. So the internet which comes from the world and which is given to you through your Wi-Fi networks or directly to your system. So that is called WAN. So I'm not getting a good example of that for the WAN. Uh, but yeah, so WAN is totally like it's called wide area network, the internet which is coming from the internet, from the world, which gives you the internet to your systems, your phones through Wi-Fi, Ethernet cards, LANs, everything. So this is called WAN. Let's talk about LAN. What's LAN? LAN is called local area network, as we talked about intranet. So intranet needs LAN, like you can be connected to the Wi-Fi and LAN both. So LAN comes, it's called local area network. Okay, so local area network itself defines that it is connected locally. As we said, if you're running an organization, or you're at home and you are connected in the same LAN, that is called intranet, and that is called to be LAN LAN. Um, let's talk about something different. Let me think. Yeah, we can say local and network printers. So yes, local printers are like the printer which is connected through a USB to your system. That is called a local printer. The network printer is like the printer which can be connected through internet via Wi-Fi or a LAN. Can be called as network printer. So what is the difference between a local and a network printer? So network printer, you can share it easily through the network in all of the systems. You don't need any sharing permissions. You just install the software in your system, and if the printer is connected in the same network you are connected, you can install that printer to your system. But local printer, can you share the printer to the same network? Yes, you can. Windows itself gives a feature of sharing the local printer to your network. So there are options of sharing printers in your system, from where you can share printers to your same network, but you have to make sure that you have to um, turn on the sharing permissions in your system, so you can share the local printers as well in the same network. And you like if you are having 10 systems in the same network, you can share the same printer in the same network. So this is called a local and a network printer. Let's check me some of the topics. Okay, let's talk about some Active Directory uses. As I was checking the PDF up was and me that you guys are going to have the Active Directory sessions as well. So let's talk about that. What is an Active Directory? What's an AD? So Active Directory is like an environment, a controller or a server that is used in an organization to, you don't have to create users in the laptop. You can create users from the Active Directory, and you can, if it is a roaming profile. So Active Directory is very vast. So I'm just going to give you an overview for the Active Directory. You can create users from Active Directory, and then if you're in the same organization, like if you're in the same network over there in an office, you can log in from any of the systems with the same user ID and the password. And if the systems are also in domain, for that you need to add all the systems in the domain. So what is domain? What is DNS? So this everything comes into the Active Directory. You can manage a DHCP server from the Active Directory. You can manage DNS, domains. You can create domain in the local environment, and then you can use network level based security as well from there. Um, we can say you can run group policies as well. If you have a local printer connected to your Active Directory, you can create a group policy with that, and you can share printers from there. You can do patches of Windows updates from an Active Directory, so that is called a different thing, WSUS. uh, you can like change wallpapers from for everyone from a single system from an 80. um, a- and you can do a file sharing server. You can create a VPN server from Active Directory. So Active Directory is very vast for this. Okay, let's check other topics. Let's talk about DHCP. So what's DHCP? DHCP is a protocol in the network where you can um, uh, if you DHCP. How can I explain you in a good way so you don't get confused? Um, Yeah. So DHCP is like you are connected in the network, right? So how will your system know that you needs an IP? So that comes then DHCP server comes into the picture. So every network thing, like every router has that protocol in their system. Like every router has the DHCP server protocol. So DHCP server, what it does, like there is a subnet mask. So let's say an example 255.255.255.0. This is a subnet mask, and DHCP, and you're running as a DHCP server. So let's talk about subnets before moving further to DHCP. Basically, what is a standard DHCP server that we use in the organization? It's /24 subnet. So subnets are very wide. We need to learn. If you want to learn about subnets, you can go ahead. But what we guys do, like we use a calculator because subnet is very wide. So let's talk about /24 subnet. So /24 subnet is called 255.255.255.0, and in that it comes 254 IPs. Okay, so 255 IPs. One is the host IP, and there is one a gateway IP, and there are 253 usable IPs that you can use in a DHCP server. So, what does a subnet does? Subnet mask gives to the DHCP server, like there are it's called a DORA process. Okay, so your system sends a request to the router that you need an IP. The router goes to the subnets and check in the network like how many IPs are free, and from then router gives you an IP address which releases the IP address to your system, and then your system gets connected to the server. So that is a process DHCP server follows. So it checks how many IPs are available, and although you can restrict the if you have 253 usable IPs, so you can restrict that as well. You can use 100 IP range. Let's say an example, you are running a range of 192.168.0.1 to 192.168.0.254. So you can use 192.168.0.2 to 192.168.0.100 as a DHCP server, and rest the other IPs you can use as manual IPs in your system. So that is a DHCP server. It's also a very vast kind of process. Um, DHCP, it's done.
Guest is having some network issues. He will be joining back within a couple of minutes. Sorry for inconvenience. Please stay on.
Upper, am I audible? Sorry, I went off.
Yes, you're audible.
Okay, perfect. So yeah, let's talk about virtual private network. So what is a VPN? It's what is a virtual private network? So if you will say in in the language of what's written in books, it's a network. A VPN extends a private network across a public network such as internet. So uh, if the it enables you to send and receive data across the shared or public networks, right? So of their computing devices, which are directly connected to the private network. So what is a private network? So private network, it's your own network in the organization. Applications running across the VPN may therefore benefit from the functionality, right? Security or management of private networks. So VPN may allow us securely access corporate internet while located outside the office. If you're not in the office and you want to access the data of the office, so you can use VPN. um, if there is a VPN setup like a SSL VPN setup in your office through a firewall or Windows server, you can get connected to the office network if you're working from home. So like as we know, we majorly are working from home now due to this new normal. So VPN helps you to get connected to a public network, to a private network if you're in the public, right? If you're working from home and you want to access some data at the office and you don't have the access through any of the other remote management tools, so you can get connected to the VPN and you can like you can get into the network of your office, and you can access the shared files which are shared with you. You can use your system as well if you're connected to a site to site VPN or a LTTP VPN in your system. So there are different protocols in VPN as well. So SSL VPN, what is SSL VPN? Majorly SSL VPNs is used in firewalls. The L2TP VPNs is used for Windows VPN, like the a VPN which is connected through a Windows server, and it is set up in a Active Directory, so you can use that L2TP uh, VPN. And site to site VPN, it's the connection between two internets through two routers. So that's called site to site VPN. Um, let's talk about what's SSL VPN. So, yeah, SSL VPN. You can use SSL VPN as well, and the from the Windows Active Directory. So, yeah. Mm, let's take another example. Okay, so remote access VPN. Uh, not the remote access VPN. We can say. mm, let's talk about ISDN, Integrated Service Digital Network. So, what is an ISDN? ISDN is a set of communication, digital transmission of voice, video, data, and other network services over traditional circuits or public switched telephone network. Key feature of ISDN is that is it integrates speech and data on some lines, adding features that we are not available in classic telephone system. So yeah, and ISDN is a circuit switched telephone network system, which also provides the access to your uh, packet switched networks designed to allow digital transmission of voice and data over ordinary telephone copper wires, resulting in potentially better voice quality. So, what are the types of ISDN? So, let's talk about what are the types of VPN. So, types of ISDN are barter channel, data channel, and hybrid channel. So, you can say B channel, D channel, and H channel. We can talk more about this later on. We can start with another topic. Mm, what's PSTN? We talked about ISTN. Let's talk about PSTN. PSTN consists of telephone lines, fiber optic cables, microwave transmissions, cellular networks, communication satellites. So that's called PSTN. And what's PSTN? It's public switching telephone network. So PSTN is an aggregate of world's circuit switch to telephone networks that are operated by national, region, or local telephone operators. So that's called PSTN. And um, PSTN is like regular telephone services that gives a data dial tone and ability to dial voice or digital data communications over ordinary telephone lines. The service sets user path between calling and called party and maintains it for the duration of call, known as PSTN. So, what's the architecture of PSTN? Let's talk about the architecture of PSTN. The architecture of PSTN. Uh, uh, there are some classes. So it starts with the class one, that's called regional office. Then comes the class two, which is called sectional office, and then comes the class three, that is called primary office, and then comes the class four, that's called tall office. And what comes in the tall office? Okay, no, yeah, what comes in the tall office? So um let's talk about the class 5 as well. It's called the end office. Okay, so this is architecture. Like, it starts from regional office, sectional office, primary office, tall office, and then end office. Okay, so when users dials a single digit to small bus of analog signal over sent, when users dials 100, six analog signals are sent, right? um so this was an architecture. Let's talk about UPN. Mm, UPN. UPN is called user principal name. Okay, the distinguished names that are used by applications and services when they communicate with Active Directory, but they are not easy for user to understand, uh, that or type understand or remember. Hence, each user has UPN that consists of a username and a suffix separated by at the rate symbol. So, uh, like let's say an example. You all guys have a Gmail ID, so it's separated by the at the rate symbol. Like, for an example, XYZ at the rate gmail.com, or ABC at the rate gmail.com. So that's called UPN. Um, What's GUID? Let's talk about GUID. It's a global unique identification. Okay, so every object in tree has a global unique identification. So GUID consists of 128 numbers that automatically assigned to a directory system when object is created. So, uh, like, if we say domain name changes, if you move the object to a different container, but GUID is permanent and server has ultimate identifier of the object. So that's called GUID. Mm, let's talk about something else. Ldap. Let's talk about LDAP. Uh, what's LDAP? Lightweight Directory Access Protocol. So, uh, the protocol for enabling anyone to locate the data about organization, individuals, and other resources such as files and devices in a network. So that's called LDAP. And LDAP, it's like a lightweight version, smaller version of code of directory access protocols. DAP DAP is a part of X500 protocol in Ldap. So X500 DAP, we can see using Ldap we can create access active directory, like I said. Ldap, it creates um, it's type of user, like yeah. Example, let's talk about an example. When you log in into your system, um, and it asks for you the user ID. Like you might be having a your Purdue University user ID with you, and it asks you for the user ID and password. Your enrollment number and password is stored in the university's Active Directory, right? So if it is not stored, you will not be able to log in. Okay, so it's already stored in the credentials are stored in the Active Directory. So using LDAP, the credentials entered by you are cross-checked with your data in AD. Okay, so AD checks your data when it verifies as you it checks your data, that if you have the permissions to log in. If you don't, if it will give you an error that you don't, your system is logged or your system is disabled. So it verifies that. So common uses of LDAP is to provide a central place for authentication, meaning it stores username and password, right? So it stores your username and password. LDAPs also helps in organizations store user credentials. Um, User attributes can also be stored in LDAP, which determines what the user is allowed to access based on policies set by directory. Directory means the Active Directory. Let's talk about um, we covered Isdn, we covered VPN, we covered LDAP, we covered Pstn. What else? It's remaining. So, TCP/IP. We already talked about TCP/IPs, and what's TCP/IP? Yeah, after coming back to the networks. Okay, so what's LAN, WAN? Okay, so you are connected to the LAN network, and so what's the TCP/IP is called? So the TCP, the like the name of TCP is called Transmission Control Protocol, which controls the transmission between the system and the network. Okay, so meaning it dictates the way the data is sent and received. A TCP header is included in the data protection of each packet uses. Okay, so what's IP? It's uh, Internet Protocol. Okay, so that's an IP. Um, um, so there are various types of IP. Intranet, you can set the IPs of your system, like of you're of a kind. Whatever numbers you want to choose for an IP address, you can use that. Okay, but what is a world IP? You cannot change the world IP. The internet, the uh, if let's an example, you have an ISP at your home, like you have a broadband connection at home, and it gives you like a connection. When it starts a connection, you cannot change that IP, right? So that is called a public IP. And in the public IP there are static IPs, which you can use for various different things. We can talk about that later. So TCP is designed for reliability, not speed, because TCP has to make sure all the packets arrive in order. Loading data via TCP can take longer if some packets are missing. So What's packets? If your packets are missing, if your system is running slow, or if your internet is running slow, if the packets are dropped, you will get the internet very slow. So yeah, we can talk about that as well later on. The what's UDP/IP? User Datagram Protocol, or UDP, is another widely used transport protocol. It's faster than TCP, but it is also reliable. Okay, so UDP does not make sure all packets are delivered in order, and it doesn't establish a connection before beginning or receive transmissions. So that's UDP. We can talk about now the 7 layers of networks. So there are the 7 layers is called OSI model layers. So what are that layers? Okay, so we can talk about the OSI layers. You might be having this in the future, or you might have got this layer. So um, the 7 layers. So there are three different layers which comes in the software layers, and three different layers which comes in the hardware layers. And there is just one layer which is the heart of OSI layers. We can say that's called. I'll give you. Uh, so let's talk about software layers first. Let's talk about hardware layers first. Okay, so um, physical layer. So I'll read out the names of 7 layers first. So the 7 layers starts with application layer, presentation layer, session layer, transport layer, which is the heart of OSI module, and network layer, data link layer, and physical layer. Okay, so we'll start with physical layer first, the lowest layer of OSI reference model. So it that is responsible for actual physical connection between the devices. The physical layer contains information in the form of bits. So uh, it is also responsible for transmitting individual bits from one node to your another node, from one end to another end. We can say when receiving data with this layer, uh, will get signal received and convert it into the OS and 0s and the 1s, and send them to the data link, which will put back from together. Okay, so that's called uh, physical layer. What's bit synchronization? The physical layer provides synchronization of the bits by providing a clock. Okay, so the clock controls both sender and receiver through, thus providing synchronization at a bit level. So that's called bit synchronization. Um, what is bitrate control? So we this all of comes into the physical layer. Okay, so what is physical control? Bitrate control. So the physical layer also defines the transmission rate, that is number of bits sent per second. So what's bits sent per second? Like how many we say, like we got 1 GB of per day data from our network provider. So how that is defined? So it calculates in the bits, then it converts into the MBs and then GBs. So that is called bitrate control. What is physical topologies in the physical layer? So physical layer specifies the way in which the different devices nodes are arranged in a network. So that is bus star or mesh topology. So this is big topology. We can talk about bus star or mesh topology. um, let's talk about the star topology. No, we can cover the topologies afterwards. Okay, transmission mode, the last mode of the we can say physical layer. So what's transmission mode? The physical layer also defines the way in which the data flows between two connected devices. The various transmission modes possible are simplex, half duplex, and full duplex. So hub repeater modems, physical cables, and physical layer devices, and network layer, data link layer, and physical are also known as lower layers and hardware layers. Okay, so let's talk about the layer 2, that is called data link layer, DLL, we say. So, what's the data link layer? What's DLL? The data link layer is responsible from a node to node delivery of a message. The main function of this layer is to make sure the data transfer is error free and from one node to another. Over the physical layer, when a packet arrives in a network, okay, so it is response. Uh, uh, when a packet arrives in a network, it is responsibility of a DLL to transmit it to the host using a MAC address. MAC address is also a wide topic we can talk about afterwards. Data link layer is also divided into two sublayers. So there is it's divided into two. It's LLC and MAC. So MAC, that's called MAC address. Logical link control and media access control. The packet received from the network layer is further divided into frames depending on the frame size of NIC. That is called network interface card. DLL also encapsulates sender and receiver's MAC address in the header. Okay, so it also recalculates your MAC address as well. The receiver's MAC address is obtained by the placing an ARP address resolution protocol. ARP is also a protocol in the networking we can talk about. Request onto the wiring asking who has the who has that IP address. So uh, uh, we if we check in the ARP, let's not jump into the ARP, and the destination host will reply with its MAC address. Okay, so the function of the data links. What are the functions? So there are basically five functions of data layers. So we can say framing, physical addressing, error control, flow control, access control. So these are the five functions of data layer. Now let's talk about framing. Framing is a function of a data link layer. It provides a way for a sender to transmit a set of bits that are meaningful to the receiver. This can be accomplished by attached special bit patterns of the beginning and end of the frame. So that's called framing. Um, the rest others are not it's not I will take time to elaborate, so we don't have much time, so I'll just go in with an overview. It's physical addressing, error control, flow control, and access control. um, let's talk about the third layer. It's called network layer. Mm, what's the network layer? What is a network layer? Let's say the network layer works for the transmission of data from one host to the other located in a different network. It is also take care of packet routing, section selection of the shortest path to transmit the packet from the number of routes available. The senders and receivers IPs are placed in the header by the network layer. The functions on the so there are basically two functions of network layers. One is routing and the other is logical addressing. So what is routing? The network layer protocols determines which route is suitable from source to the destinations. Like if you're sending a ping to from a to a Google. So like if you're going to search google.com, uh, it finds the shortest way to resolve the name resolvers, that is called DNS, and it gives you it we can say the fastest routing protocol. Okay, so the function of the network layer is also known as routing, which 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 routes you from the suitable from source to destination. It gives you resolves the IP address to the name resolvers very soon. So that's called routing. So um, what's logical addressing? In order to identify each device on inter network uniquely, the network layer, which defines an addressing scheme, the sender and the receiver's IP addresses are placed in the header by the network layer. Such an address distinguishes each device uniquely and universally. Okay, let's talk about the fourth layer, which is called transport layer, which is the heart of OSI model. So, what's a transport layer? The transport layer provides services to an application layer and takes services from the network layer. The data in the transport layers is referred to as segments. It is also responsible from end-to-end delivery of the complete message. The transport layer also provides the acknowledgement of the successful data transmission and retransmits the data if the error is found. So let's say an example at the sender side, transport layer receives the formatted data from upper layers, performs segmentation, and also implements flow and error control to ensure proper data transmission. It is also or it also adds source and destination port numbers in its header and forward the segmented data to the network layer. So, what is at the receiver side? So, the transport layer reads the port number from the header and forwards the data which it has received to the prospective application. It also performs sequencing and reassembling of the segmented data. So, what are the functions of transport layer? So, that's a very wide topic. I can just give it even. Uh, Overview. So, what are the functions? So, basically, majorly there are four functions: um, segmentation and assembly, service point assembly, and connection oriented services and connectionless services. So, these are the protocols in the transport layer. We can jump onto another session layer that is called session layer, layer 5. So this layer is responsible for the establishments of connection, maintenance of sessions, authentication, and also ensures security. The functions of the session layers are, like there are three functions of the session layer, which is called session establishment, maintenance, and termination, synchronization, and dialog controller. So that's also a wide topic we can talk about later on. Uh, let's talk about the layer 6, the presentation layer. So presentation layer is also called translation layer. Okay, so the data from the application layer is extracted here and manipulated as per the required format to transmit over the network. The functions of the presentation layers, there are three functions: translation, encryption, decryption, and compression. So translation, for an example, ASCII to EBCDIC. So that's a translation. Encryption, the data encryption translates the data into from another form of a code or a code. The encrypted data is also ciphertext, and decrypted data is also known as plain text. So a key value is used for encrypting as well as decrypting data. So that's a very wide topic we can talk about later. Compression reduces the number of bits that needs to be transmitted on the network. So these were the three uh, functions of the transmission layer. Uh, the seventh layer is called application layer, at the very top of the OSI model. Okay, so it's the very top layer of the OSI model. Um we find the when we find the application layer which is implemented by a network application, these application produce the data which has to be transferred over the network. This layer is also serves as a window for the application services to access the network and displaying received information to the user. Example, we can say application browsers, Skype, messengers. Okay, browsers, Skype, messengers, Facebooks, WhatsApp. So these are also these are known as applications. So application layer is also called a desktop layer as well. The function of the application layers, there are four functions of the application layer, which is called network virtual terminal, FTAM, file transfer access and management, and third is mail services, and the fourth one is the directory services. So these were the seven layers of OSI model. uh, that we talked about, we can, it's very wide, the OSI model. We can talk more about uh, OSI model in the second session if we have. Let's. I guess it's time to end. We covered majorly types of protocols. Um, Nitra, what do you want me to cover something in 5 minutes? So why do we need protocols? So let's talk about CATV. Not talk about CATV. Let's talk about why do we need protocols. So it may be that the sender and receiver of data are the parts of different networks located in a different parts, right, of the world, having different data transfer rates. So we need protocols to manage the flow control of the data, access control of the link being shared in the communication channel. Suppose there is sender X who has a data transmission rate of 10 Mbps and the receiver Y who has a data transmission of 5 Mbps. Okay, since since the rate of receiving the data is slow, so some data will be lost during the transmission. In order to avoid this, the receiver Y needs to inform sender X about the speed mismatch so that the sender X can adjust the transmission rate. Similarly, the access control decides the node which will access the link shared in the communication channel at the particular instant of time. If not transmitted, data will collide, and if many computers send data simultaneously in the same network through the same link, resulting the corruption or the loss of the data. So this is the reason we need protocols. Okay, all right, guys. I think it's uh, time to leave. I hope you enjoyed the session.
Yes, thank you so much, Himanshu, for giving all the insights and all the information to our students. At the end, I would like to thank the HOD of Computer Department, Mrs. Poonam Faldu ma'am, and HOD of IT Department, Vidita madam. I'd also like to thank Head of Institute, Professor Jatin Vaidya sir, for providing us the opportunity to conduct this webinar. So thank you all the students for attending the webinar. So we will cover up now.
Okay, thank you, guys. Stay safe.
हो गया सर. जितेन सर.